Hi students, welcome to ChemShow. Today's topic is examples of photosensitized reactions. Okay, let us start our class. First one, that is photosynthesis in plants. That is one natural and the most important and the most outstanding example of photosensitization is the photosynthesis of carbohydrates in plants from carbon dioxide and water, in which chlorophyll, the green coloring matter of plants, act as a photosensitizer. Okay, that is, chlorophyll is the photosensitizer. This reaction, photosynthesis, is an example for photosensitization reaction. That is, this is an example of photosensitized reaction. Here, chlorophyll, the green coloring matter of plants, act as a photosensitizer. That is, neither the carbon dioxide nor water absorbs any radiation in the visible region, but chlorophyll does. That is, chlorophyll is the only absorber in this reaction, light absorber. And it transfers the energy to the reactants, that is carbon dioxide and water. Okay, it is sensitizer. It absorbs visible light of almost wavelength range from 400 to 700 nanometer. Okay. The energy of the light absorbed by chlorophyll is transferred to carbon dioxide and water molecules, which then react to form the carbohydrate, that is CH2O N times. That is this C6H12O6, which can be written as C CH2 O N times, which is nothing but carbohydrate, that is C6H12O6. Okay, that is, here one natural example for photosensitization is the photosynthesis of carbohydrate in plants from carbon dioxide and water, in which chlorophyll, that is green coloring matter of plants, act as a photosensitizer. Here, neither the carbon dioxide nor water vapor absorbs visible solar radiation, but chlorophyll, the green pigment present in leaves, absorbs the radiation and get activated and passes on the energy to the reactant. That is, reactant molecules are carbon dioxide and water. That is, it passes on the energy to the reactant molecules to affect the formation of carbohydrate with release of oxygen. Okay, that is, the process is extremely complex one. This is the simplest equation. Okay, this photosynthesis process actually involves two main stages, that is light reactions and dark reactions. There are two main stages of photosynthesis reaction. Actually, it is a complex reaction. It is divided into two main stages, light reactions and dark reactions, and so on. Okay, this is the simplest equation of the photosynthesis process. Okay. Okay, I'm asking one question. That is, why does chlorophyll molecule, that is, why does chlorophyll molecule absorbs light energy? What is the reason behind this? Can you say or guess why this is acting as a photosensitizer? Can you guess? Does why this chlorophyll acting as a photosensitizer, or why it is absorbing light? There is the reason behind this is the extensive conjugated system of chlorophyll molecule. That is the reason behind this is the extensively conjugated system of alternatively single and double bonds, which helps the molecule to absorb visible radiation. Okay, that is, chlorophyll contains extensively conjugated system of alternately single and double bond. That is, conjugation means single bond, one double bond, single bond, and so on. No? Okay, that is the reason behind the chlorophyll is absorbing light. This chlorophyll contain an extensively conjugated system of alternately single and double bonds, which helps the molecule to absorb visible radiation. Okay. Next we are discussing the second example of photosensitized reaction. This photosensitized dissociation of molecular hydrogen into atoms. That is, molecular hydrogen. This molecular hydrogen does not dissociate into atoms when irradiated with wavelength of 253.7 nanometer. That is, when molecular hydrogen, that is, this molecular hydrogen does not dissociate into atoms when irradiated with a radiation of wavelength 253.7 nanometer. But when hydrogen is mixed with mercury, that is mercury vapor, photosensitizes the dissociation of molecular hydrogen into atoms, into its atoms upon 253.7 nanometer irradiation. That is, here mercury is acting as a photosensitizer. Here mercury is the photosensitizer. Okay. The irradiation of a mixture of hydrogen gas and mercury vapor with light of wavelength 253.7 nanometer brings about dissociation of hydrogen molecule into hydrogen atoms. That is, Hg plus Hnu gives Hg star, which is the photosensitizer, which is giving its energy to this molecular hydrogen and helping them to dissociate into its atoms. Okay, that is, here Hg, mercury vapor, is acting as a photosensitizer. Next we are discussing a third example, that is the photosensitized isomerization of butene 2, that is 2-butene. Isomerization means that is cis-butene 2-butene is converted into trans-2-butene. Okay. That is SO2. Here SO2 is acting as a photosensitizer. That is, SO2 photosensitizes the isomerization of cis-butene 2, that is cis-2-butene into trans-2-butene. Okay, upon irradiation of 253.7 nanometer wavelength of radiation. Okay, that is here SO2 is acting as a photosensitizer. The cis-butene 2 undergoes isomerization to yield trans-butene 2 when exposed to radiation of 253.7 nanometer wavelength in the presence of sulfur dioxide. That is, in the absence of sulfur dioxide, this reaction does not happen. Okay, here this reaction is taking place only with the assistance of what? Sulfur dioxide, which is called a third substance, that is photosensitizer. Okay, if you have any doubts regarding this section, you can ask doubts in the comment section. Okay, let us wind up the section. Thank you.